Multiplication, remember, is AB, A dot B, A parenthesis B. You can turn any division problem into multiplication. So if we have A divided by B, how can we turn that into a multiplication problem and still get the same outcome as A over B? That is a good question. Okay, plus we would multiply by what? Reciprocal. We're on the right track. So what would I multiply A by to get the fraction A over B? Just B? A times what will equal A over B? A times B would be AB. A times what will give me A over B? Do you remember how to multiply fractions? Good. So if I multiply by 1 over B, that would equal A over B. So remember, whenever you have a fraction, if you take the top off, there's just a 1 left. And this right here, I can put over 1. So A times 1 is A, 1 times B is B. That gives me A over B. Okay? So multiplication and division, they're the same thing. You can change a division problem to be a multiplication problem. That's why Gemma lets you do both. Our last one is additive operations. Additive operations. So let's start with addition first. Addition would be like A plus B. Okay, we got a plus sign. A plus B. Addition also corresponds with subtraction. So addition can also be written with subtraction. They're the same thing. So how could we turn A minus B into an addition problem? How can we turn A minus B into an addition problem? But it still be A minus B. That would, A minus negative B. Okay, we could do A minus negative B, but that would change that to plus. How can I do A plus what would give me A minus B? I can't do A minus negative B because that would change what this equation says. It would change it to A plus. I want to write A minus B, but with addition. So if I do A minus negative B, that would change this to A plus B. I want to keep it A minus B. So A plus what? There, negative B. If I do the double negative, it'll make it plus. No, it's weird. I'm sorry. So A minus B is the same thing as A plus negative B. So the subtraction is the same thing as addition. I can change any subtraction problem into an addition problem. All right? So on page 4,